Hey there, science explorers! Have you ever wondered what makes up everything around you? What if I told you that the entire universe, from the tiniest grain of sand to the vast galaxies, is made up of the same fundamental components? Intrigued? Well, let's dive in and uncover the secrets of matter and energy together. From the chair you're sitting on to the air you breathe, it's all matter and energy. Matter is anything that occupies space and has mass. It can be as solid as a rock or as invisible as the air around us. Energy, on the other hand, is what makes things happen. It's the force that moves objects, heats our homes, and powers our gadgets. Get ready to unlock the mysteries of the universe as we dive into the exciting world of atoms, molecules, and the incredible transformations they undergo. Atoms are the building blocks of matter, tiny particles that combine in countless ways to form everything we see and touch. Molecules are groups of atoms bonded together, creating the substances that make up our world. Matter is anything that takes up space and has mass. This means that everything you can see, touch, or even smell is made of matter. Scientists measure matter in terms of mass, which is the amount of material in an object, and volume, which is the space it occupies. Think about it, your phone, a slice of pizza, even you, it's all matter. Each of these objects is made up of atoms and molecules arranged in specific ways to give them their unique properties. For example, the atoms in your phone are arranged to create circuits and screens, while the atoms in a slice of pizza are arranged to create delicious flavors and textures. Energy, on the other hand, is the ability to do work or cause change. It comes in many forms, such as light, heat, and motion. When you turn on a light bulb, electrical energy is converted into light energy. When you ride a roller coaster, potential energy is converted into kinetic energy, giving you that thrilling rush. Remember that roller coaster ride? That's energy in action. The energy stored at the top of the ride is released as the coaster speeds down the track, converting potential energy into kinetic energy. This transformation of energy is what makes the ride so exhilarating. Now, let's get ready to explore the building blocks of matter and the powerful forces that make our world so dynamic. The periodic table of elements is like a map of all the different types of atoms that exist. Each element has unique properties and can combine with other elements to form new substances through chemical reactions. Get ready for an adventure in the world of chemistry, where we'll uncover the secrets of matter and energy. Chemistry is the study of how substances interact, combine, and change. It's all about understanding the reactions that make up our everyday lives, from the food we eat to the air we breathe. We'll explore the amazing reactions that make our world so interesting, from the food we eat to the technology we use every day. Cooking, for example, is a series of chemical reactions that transform raw ingredients into delicious meals. Similarly, the technology in our smartphones relies on chemical reactions to function. So, buckle up, science fans, because things are about to get elemental. We'll journey through the periodic table, discover how elements combine to form compounds, and see how these compounds create the materials and energy sources that power our world. Get ready to be amazed by the wonders of matter and energy. Let's talk about chemical formulas, the secret code of chemistry. These formulas are like the language that chemists use to describe the world around us. They might look complicated at first, but once you understand the basics, they become a powerful tool for understanding how substances interact and change. Think of these formulas as recipes that tell us exactly what elements are involved in a chemical reaction, and in what proportions. Just like a recipe for a cake tells you how much flour, sugar, and eggs you need, a chemical formula tells you how many atoms of each element are in a molecule. Each element is represented by a unique symbol, usually one or two letters. For example, H stands for hydrogen, O stands for oxygen, and C stands for carbon. These symbols are like the ingredients in our chemical recipe. Take water, for example. Its chemical formula is H2O. This tells us that each water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. It's a simple formula, but it tells us a lot about the composition of water. That means each water molecule has 2 hydrogen atoms, H, and 1 oxygen atom, O. This specific combination of atoms gives water its unique properties, like its ability to dissolve many substances and its high boiling point. Pretty cool, right? Atoms are like tiny building blocks. They are the fundamental units of matter, and everything around us is made up of these building blocks. By understanding how atoms combine to form molecules, we can understand the properties of different substances. They're the smallest unit of an element that still has the properties of that element. For example, a single atom of gold is still gold, with all the properties that make gold unique, like its color and density. Molecules are formed when 2 or more atoms bond together. These bonds are like the glue that holds the atoms together, and they can be strong or weak depending on the elements involved. They can be made of the same type of atom, like an oxygen molecule, O2, which consists of 2 oxygen atoms bonded together. This is why we breathe in O2. It's the form of oxygen that our bodies can use. Or they can be made of different types of atoms, like water, H2O. The combination of hydrogen and oxygen atoms gives water its unique properties, making it essential for life as we know it. Understanding these chemical formulas helps us unlock the secrets of the natural world and harness the power of chemistry in our everyday lives. Acids and bases are everywhere. Lemons and vinegar are acidic, giving them a sour taste. Baking soda and soap are basic, which helps them neutralize acids. We measure acids and bases using the pH scale. The pH scale goes from 0 to 14. Acids are below 7 and bases are above 7. Right in the middle, at 7, are neutral substances like pure water. Acids and bases can react with each other in a process called neutralization. For example, when you mix vinegar, acidic, with baking soda, basic, they fizz. That's because they're neutralizing each other, producing water and a salt. Here's a fundamental law of the universe, the law of conservation of mass. It states that matter cannot be created or destroyed, only transformed. Imagine burning a piece of wood. It seems like the wood disappears, right? But it doesn't actually vanish. The wood reacts with oxygen in the air, transforming into ash, smoke, and gases. If you could measure the mass of all the products, ash, smoke, gases, it would equal the mass of the original wood and the oxygen it used up. So matter is never truly gone, it just changes forms. Let's talk about how matter can change. There are two main types of changes, physical and chemical. Physical changes are like changing your hairstyle. The substance is still the same, it just looks different. For example, melting ice is a physical change. The water is still water, just in liquid form instead of solid. Cutting a piece of paper is another example of a physical change. Chemical changes, however, are like baking a cake. You start with simple ingredients, but end up with something totally new. Chemical changes result in new substances being formed with different properties. How can we tell if a chemical change has occurred? Look for these telltale signs. Color change, like a rusty nail or a banana turning brown. Gas production, like bubbles forming when you mix baking soda and vinegar. Temperature change, like heat released when wood burns or absorbed when an ice pack gets cold. Formation of a precipitate, which is a solid forming when you mix two liquids. Remember, these are just clues. Sometimes a physical change can also show some of these signs. But if you see several of these signs together, it's a good bet that a chemical change has taken place. Now, let's meet the diverse families of matter metals, nonmetals, and metalloids. These three categories encompass the vast array of elements that make up everything around us. From the air we breathe to the gadgets we use, each element has unique properties that define its role in our world. Metals like shiny gold and strong iron are great conductors of heat and electricity. This is why metals are often used in electrical wiring and cookware. Their ability to conduct heat efficiently makes them ideal for pots and pans, while their electrical conductivity is crucial for wiring in homes and electronic devices. They're also malleable, meaning you can shape them, and ductile, meaning you can stretch them into wires. This malleability allows metals to be hammered into thin sheets, which is why we see metal foils in kitchens and packaging. Their ductility is why metals are drawn into wires, making them indispensable in construction and manufacturing. Nonmetals, like oxygen and carbon, are the opposite. They don't conduct heat or electricity well, which is why materials like rubber and wood are used as insulators. Oxygen, a gas, is essential for respiration, while carbon, in its various forms, is a fundamental building block of life. They're poor conductors of heat and electricity, and tend to be brittle. This brittleness means nonmetals can break or shatter easily, unlike metals which can bend without breaking. This property is why nonmetals are often used in applications where flexibility is not required. Metalloids, like silicon and germanium, are the in-betweeners. They exhibit properties of both metals and nonmetals, making them incredibly versatile. Silicon, for instance, is a key component in semiconductors, which are the backbone of modern electronics. They have properties of both metals and nonmetals. This dual nature allows metalloids to be used in a variety of applications, from computer chips to solar cells. Their unique properties make them invaluable in the tech industry. These differences in properties are due to the way their atoms are arranged and how they bond with each other. The atomic structure determines whether an element will be a good conductor, malleable, or brittle. Understanding atomic bonding helps scientists and engineers design materials with specific properties for various uses. Understanding these differences helps us use these materials effectively in everyday life. From the construction of buildings to the creation of electronic devices, knowing the properties of metals, nonmetals, and metalloids allows us to choose the right material for the right job. This knowledge is fundamental in advancing technology and improving our daily lives. Congratulations, science adventurers. You've journeyed through the fascinating world of matter and energy, uncovering the secrets of atoms, molecules, and the incredible transformations they undergo. Remember, science is more than just facts in a textbook. It's a way of observing, questioning, and exploring the world around us. So, keep those thinking caps on and never stop asking why. From the smallest atom to the largest star, there's always more to discover in the amazing universe of science.